Good.
Good. Good.
Good.
Are you able to hear me, Professor?
Pardon me?
Are you able to hear me? Am I coming through?
Yeah, you are coming.
Okay.
Yeah. Oh, okay. A lot of you are here already. Oh, we have 20-something people already. Okay, we'll start soon. Okay.
Okay.
Let me just grab my notes and so on. Okay.
Okay.
I just finished my lunch.
Hello. The purpose? Why? Check. Anybody hear me?
Yeah.
Oh, stop.
You guys can see the board, okay?
Yes.
The whiteboard.
Yeah.
It was from leftover from my calculus 2 class. We are talking about logistic model. You guys recognize all this?
Mm-hmm.
Yeah. Can anyone hear me?
I want to let you know that I'm not recording. I'm not recording the class. I mean, I'm just delivering it. If you guys want to record it, you're welcome to do that. If you have a volunteer who record it and then post it, you can just record your own desktop. You don't need permission from me to record your own desktop. And then put it on YouTube or something. Anybody plan to do that?
Check.
Did somebody say sure? I guess
to do it.
Who's going to do it? Robert? No, I'm not forcing anybody to do it. I'm just telling you I'm not doing it.
No, I can't do it.
That's just fine. You can just do whatever.
Hans is doing it.
Who's doing it?
Hans.
Oh, Hans is doing it. Fantastic. You do it. You can just post the link on the discussion portion of the on Canvas. There's a tab called discussion. Just post the link there. Yeah, that will work. Okay, so everybody be safe, okay? This is difficult time for everyone. I know it's stressful for everybody.
If this gets extended past when we were supposed to have our second exam, what are we gonna do in that case?
The second exam, I have no idea currently. I think I need to figure it out. I kind of don't know what to do, but I may likely end up doing online.
Mm-hmm.
Just I haven't decided, but very likely it will be just online. I'll just choose some problem from Map Assign, and will be open book and open notes. I'm not going to be able to monitor you. I'll just choose some problem.
Yeah,
And
some
I'll
of
give
those.
you, I don't know, how many tries do you need? The standard for the test in web assign is 2 tries. Is it too scary? 2 tries?
Yes.
Is it 3 tries? Okay. My pre-calculus class set them on 3 tries.
About 5.
What?
No, I'm just saying. How about 5? It's fine. 3 is good.
Do you guys feel okay with 3? I understand. I mean, the format of the answer and all this stuff may trip you up.
3 seems fair.
Okay, that's good. Then we'll settle on 3. You need to be careful though, okay? When you do a plus C, I mean a capital C and small c, they mark you off. You lose the whole thing. You know what I'm talking about?
Mm-hmm.
Mm-hmm.
You need to be really careful. Yeah, you need to be very careful when you type the thing in. So I won't be able to monitor you. You can do whatever you want, basically. Okay.
Mm-hmm.
Look at the notes, look at whatever. I don't know.
Yeah, we're kind
So-
of uncharted territory.
That's probably, I haven't completely designed, okay? Because it's going to be a nightmare for you to just ask you to do it written. Okay, if I do a written test, I'll end up with all these tests in PDF format. And I have to scroll through every single one of them to grade, which is very hard to grade. If I have a piece of paper, it's much easier to grade. Yeah. So that's what I likely will do. I haven't completely decided. Any other question logistically? I forget when are we supposed to have the test? Shortly after the break, right?
Yeah.
Is it one-
Yeah.
1 week after the break or something?
Mm-hmm. But the lockdown, at least in the counties, is till the 7th, I believe. So
The lockdown, I don't know the official thing.
yeah.
What I believe is likely until the end of the semester.
Yeah.
Professor, originally the test was supposed to be on April 7th,
Oh, there we go.
but yeah, I don't know if you still want to do that.
Yeah, the test is on April 7th. I may postpone it a little bit, but I don't really know currently. Okay, it may get postponed a little bit. Because I'm still trying to figure things out. I'm trying to do an online test with my pre-calculus class and see how it goes. But the pre-calculus questions are much easier questions, so it's different. Okay, they will have more questions, but here you guys will have less questions. But it's really, sometimes it's hard to get it completely correct. Okay, so you guys need to be very careful when you type in your answer.
With
Okay.
stuff like that, are you able to see like our previous submissions per question? So that like if it says we got it wrong, but if it shows in our answer like that you can accept one of our solutions that it quote marked wrong.
Yeah, I don't really know exactly, but we can. I'm doing a mock test first with the other class, and then this next week, and then an actual test. Okay.
Mhm.
And then if we feel that we need it, we can also do a mock test with you guys. Okay.
Okay.
To see what I can see. I mean, so it will be good if I can see the previous 2 tries, right?
Mm-hmm.
And see how close it is. But
Yeah.
the third one, if I just see the last one, it still tell me a lot about how close you are, though. You know what I'm saying? The third one, if you're just like the big C become a small c and they mark you wrong, I probably will give you credit
Really?
for that problem. Okay.
Will there be a time limit on the test?
Will be a what?
A time limit?
Yeah.
Okay, cool.
The time limit is the only thing that I can control, you guys.
Okay.
Everything else, I don't know. I mean, you can look at your book, you don't know. Some of you may Google it. I don't know. I don't know what you will do. The only control I have is the time limit and the number of tries.
But you can connect on Bluetooth.
What? Okay, are you guys ready? We are going to start the lecture.
Yes.
Yes, sir.
Okay. I actually did this example last time. That's 4.9, guys.
Some guy was moving in today.
Oh, you parked there?
Yeah.
When, last night?
Yeah.
The one's gonna go truck. Even if you park in the red zone, they're gonna tow you.
Okay, yeah, they'll tell you. They'll tell me when I wasn't in the red zone. Are you ready?
How come I hear this squeaking noise on the background constantly?
I know.
Okay. Better. It's gone now. I forgot where I was. I did this problem, is that right? Last time. I have to be careful on how to use the space on the board because yeah. Can you guys see?
Yes, it's visible. Thank you.
Okay, you're welcome. X is a function of time. So X and Y are both. X is function of time, Y is function of time. Okay. And the way to solve these things, there are many ways. As I said last time, you can do linear algebra stuff, eigenvalue, eigenvectors. You can do the elimination. Okay, this is like Math 120 type stuff. I don't remember exactly where I was on this problem. I'm just going to redo the whole
You
thing.
found x of t.
We finished it.
I find X of t
Yeah, you
And
found
y of
x of
t.
t.
and Y of t.
Mhm.
I find Y of t using X of t, right? Yes, I find Y of t using X of t. You can also okay. Good. I know what I've done last time. This is what we did last time. This is what we did, right?
Yeah.
And then we try to. What we try to do is that. I probably should line this up. Minus 2x plus dy equal to 0. Last time I eliminate y. Okay.
Mhm.
I eliminate y. Do I have to repeat how I eliminate y? Or can I just say I eliminate y, I get this? Is this what I have last time?
Yes.
Yeah,
Yes.
that's
Okay.
correct.
And then from this, what I did last time is that from here, you differentiate this will be 3y, right? So 3y is equal to x prime t, which will be differentiate this. I did this part too last time. Okay, so y will be 1/3 of this. Is it okay? Is that what we have last time? Exactly stop here last time? Can you guys tell me whether that's correct? Did I stop right here last time?
Yes, you did.
Okay. Thank you. Now, of course, you can do it some other way. You can do eliminate x and get y first. And the procedure will be the same. Maybe you guys can help me to eliminate x to get y. How do I eliminate x? The first equation I multiply by 2. 2 dx minus 6y equal to 0. The second equation, what do I do?
You keep it the same, just add it.
I just d it, right? I d the second equation.
Yes.
I differentiate the second equation. Will be minus 2 dx plus d squared y equal to 0. And then what happened? What do I do next? What do I do next? What do I do next?
You just add them up.
Just add them up. So the x will be gone. And then I end up with d squared minus 6y equal to 0. And then you have m equal to what? Plus or minus square root 6. Is it okay?
Mm-hmm.
So y will be some constant. Now I'm going to call this a little bit C3 Is it okay? C3 and C4. Okay. I could have called it C1 and C2, but I just don't want to confuse it with the C1, C2 over here. Is that all right? Are you guys following me?
Mm-hmm.
Yes.
So from this, how do I get X? How do I get xt from this? You can put it back into over here. So x will be 1/2 dy dt. So you differentiate this guy. So minus square root 6 over 2 C3. Is it okay? You guys good until here?
Yes.
I mean, both of these are the same, okay? So those are the, so the answer either look like this or look like this is one set of answer, the one in red, the one in green is another set of answer. Okay? This is another set of answer. Okay? So both of them are the same. Any questions? Are you guys okay?
Mm-hmm.
So, in general, now in this both of this, in the way that I do it, we are kind of lucky. We are kind of lucky. Lucky in the sense that from you can just get the x and you put it back, then you can get the y. or you get the y and put it back, and then you can get the x. But it's not always the case like that. The general procedure is actually slightly different from this, because sometimes you cannot do it that way. Okay? Sometimes you will have to do it some other way. Okay? So the general procedure is actually the following. The general procedure is that you end up with this guy, and you end up with this guy, and you have to get a relationship between C1, C2, C3, and C4. Okay? Based on what happened here originally. Do I confuse you a lot?
A little bit.
Okay. Let me just go ahead and do that procedure. But up till here is okay, right?
Yes.
So up till here is okay. I'm just trying to say that in general,
Sure.
it's kind of lucky because we put the x, because these equations are quite simple. Once you get the x, based on the x, you take the derivative, you can get the y. It's okay?
Mm-hmm.
And in another case, you start out with the y, you take the derivative, you get the x. But it's not always like that. Okay, so you can have situation where it's slightly more complicated. Okay, maybe we can do an example like that after this example.
Professor, before you move on, can you show us how to do it using linear algebra real quick, if you don't mind?
I can talk through it very quickly.
Yeah, that would work.
Okay. For those who don't have linear algebra, don't worry about it. I'm not going to spend too much time on it. dx dt is 3y. This is an equation. Okay. In linear algebra, we diagonalize this matrix to decouple them, basically using a change of basis. Okay. So that this thing become a diagonal matrix. Now this is not a diagonal matrix. This is the other way. You can do diagonalization and then change your basis. Basically, you tilt your coordinate system around so that this guy will end up with some kind of like x bar prime equal to the eigenvalue, say lambda 1 x bar itself, y bar prime equal to lambda 2 y bar. And each of these, the answer will be an exponential function. And then you have to undo the coordinate system, do the reverse one to get it back into the original coordinate system.
Okay, thank you.
No problem. We actually will probably do it in the Math 270 this semester. At least that was the plan until this thing hit us. I don't know whether we have enough time, but I was planning to do it. Okay, so I'm going to show you still using this example, how to base on this and this. The two, I have a black star on it to find out the relationship between C3 and C4. And that is actually the general method. Okay?
Library? Would you like to put the music in?
What? Miguel? Did you say something, Miguel?
Yeah.
Can you say that again?
It was nothing. I was just testing the audio.
Oh, okay. Now, so this is what I'm going to do next, okay? I'm going to base on this guy and this guy, whatever is left, those here on the board. Okay? And the original functions. Okay, I'm going to use this. Okay? I'm going to find the relationship between C1, C2, C3, C4. This is the general method. Okay, usually you have to eliminate x to get y, eliminate y to get x, and then try to do the relationship. Okay, maybe I even write down the general procedure. Eliminate x, and then you get y, and then you eliminate y, then you get x. Okay, and then put xt, yt back into original equations to find relationship between the constants. Okay, because you're not supposed to get 4 constants. Okay, you're not supposed to get 4 parameters. You have 2 first order equations. You're supposed to get only 2 parameters. Okay, so there are relationship between the C3, C4, and C1, C2. Okay, so the way to do this is that put these answers back into the original equation. So if xt is this, so what will be dx dt? Dx dt is what? If x is this, dx dt will be minus square root 6 c1 plus square root 6 c2. Okay. We okay? And that is supposed to be equal to 3y. Supposed to be equal to 3y. So this guy should be equal to 3 times this. Okay? So dx dt equal to 3y. What does that mean? That means this guy here. Once again, let me know if I make a mistake, okay? So be equal to 3 times it. Now the goal is to relate the C1, C2, C3, C4. So here, based on this, can you see the relationship between C1 and at least one relationship between C1 and C3? Because these two guys, fundamental set of solutions, they are linearly independent. Are you guys with me? This is linearly independent, right? So when these two are equal, that means minus square root 6 C1 is equal to 3 C3. And also square root 6 C2 is equal to 3 C4. Is it okay? Do you guys follow this?
Yeah.
Yeah.
Okay. So from this, I know that C3 is equal to minus square root 6 C1 divided by 3. And C4 is equal to square root 6 C2 divided by 3. So that's the relationship. Okay? And from this, you can change this to, this C3 can now be changed to minus square root 6 over 3 C1. C4 can be changed to square root 6 over 3 C2. And that is the more general method, okay? Any question? How are we doing, guys?
So then in your answer, would you, when you write down your y of t solution, do you put in the parameters
Yeah, you
in
should
terms of C1 and
replace this guy by those. Yeah. It
in
will be
terms
right.
of C1 and C2?
Yeah.
Okay.
Or you can do it the other way around. Here is C3, C4, and then you have C1, C2 in terms of C3, C4. Is it okay? I'm going to get some water, okay? I'll be back right away. Hey, Anthony, this cup is fine?
The one with the duck. The one with the duck.
Okay. You guys okay? We can find a problem from the book and then work through this together. But you guys need to help me though, okay? When I make a mistake, just like face-to-face class, let me know if I mess up. Don't let the mistake propagate. I guess you guys do want another problem, right?
Yes.
That would be
Yes,
amazing.
please.
Yeah, thank you.
Yeah.
Yeah.
No problem. Let me try to get one which is not too ridiculous. Okay, I'm going to do this problem. We are going to be brave, okay?
Mickey Minis. Oops.
Now, once again, help me out if I mess up, okay? They're doing this real time without notes. Okay. We are going to just use the general method, okay? You guys can exploit some property sometimes to shorten it. But we are not really going to do that. Just want to illustrate the general method. So first step is to rewrite this in the format of differential operator. So this will be d minus 4 x minus 7y equal to 0. X minus e plus 2y. I do it correctly, guys. You guys need to let me know.
Can you walk me through how to find that?
Can I what?
How did you get that?
Okay, that's fine. That's fine. That's okay. Yeah, I'll do that. No problem. Okay, I'll walk you through that. Here, I take the 4x to the other side. Okay, so this y d minus 4, and then I put the 7y. Can you see that now, Shannon? At least for the first one.
Oh yeah, I thought the problem was a different thing. Sorry, I thought it was 4x, not 4 minus x.
Okay, so this one will get me to, I put the dy dt on the other side, right? Yeah. Is it okay? You guys good?
Thanks.
No problem. So now we have these two equations. I'm going to label them 1 and 2. So over here, we can. Which one you want to eliminate first, guys?
Quick question.
Yes.
You have a dx dt. We're just assuming that dt disappears in this case, or
the d means dx. The capital D means ddt.
Okay.
This guy stands for ddt.
Okay.
I mean, it's kind of implicit. It's implicit. Both x and y are functions of t. Okay, so what do we do? How about eliminate x first? How do I eliminate x? I would. What do I do?
Multiply both sides by d minus the bottom equation by d minus 4. I mean,
the first one will be 2d plus 2, right? Is that what you're thinking about? D plus 2.
Sure.
It's okay, Shannon? So this
Sure,
one
thanks.
becomes d plus 2. This is not exactly multiplying, it's actually operating on it, right? It's an operator.
Mm-hmm.
Is it all right? The second one, then what? In order to eliminate x, oh my god, I did the wrong thing. I'm eliminating y actually. Sorry. Can I change it to eliminate y? I'm trying to match this one, so I will end up with x. Okay. So this guy multiplied by 7. Hey, is it still okay, guys? Did I do anything wrong? Am I good? Do you have questions?
Professor?
Yes.
For that number 2 equation, can you walk me through how you got that? Like, so you said you moved d over dt on the right side?
Yeah, this guy here.
So you subtracted it?
Yeah, I do. It's okay?
Thank you, yeah.
Any other question before we proceed, guys?
If you're eliminating y, does one of them need to be
I'm eliminating y. I'm trying to match these guys, right? I'm trying to match this guy. This is a 7 here. There's a d plus 2 here.
Yeah, so if you add it up, like if you do system of elimination, right? Isn't like for the second 2 pairs of equations, shouldn't one of those 7s be a positive?
Oh, okay, that's fine. I mean, you can do it like that. I'm going to subtract.
Okay.
You're going to add. That's fine. It's okay? It's the same thing?
Yeah.
I'm going to subtract now. Okay?
Quick question. Is that a 7x times the equation of 2 or equation 2, or is it 7x?
7 times equation 2.
Okay. So I wasn't sure.
Yeah, I just want to emphasize it's multiplying. and over there is kind of it's an operator.
It's kind of hard to tell because the screen's a little.
Okay, so this guy you can actually FOIL this, right? D square minus 2D minus 8 minus 7 minus 15. Is it okay?
Yeah.
3 and 5, right? You already know the characteristic roots. C1 e to the power 5t, C2. Yes?
Mm-hmm.
Okay, I got my X. Eliminate one. Eliminate X to get Y. Eliminate X, how do I get rid of these guys here? I just need to do D minus 4 of the second one, right? And D minus 4. D minus 4 of the second one, X minus D minus 4, D plus 2, Y equal to 0. Now, I'm going to copy equation 1. Can you guys see that now? So these two already, you can do elimination from here. Those green ones I box out. The 2 green ones I box out. I do a subtraction. Maybe I call this equation 3 now. This is equation 3. So now it's actually just 1 minus 3, right? Equation 1 minus equation 3. 1 minus 3, what do I get? I get this guy minus that guy. So we end up with D minus 4, D plus 2, minus 7. Is it okay? Do you guys follow or do I lose you?
It's okay.
It's good? Thank you, Jenna. So it looks very much the same as before. So you multiply this out, D squared minus 2D minus A minus 7 minus, this one is minus 15. Y equal to 0. It looks very much nearly the same as before. D minus 5, D plus 3, Y equal to 0. So Y is equal to, now it's not C1 and C2 anymore. It's actually C3 and C4. Is it okay? But the C1, C2, C3, C4, they are relationships. Okay? Now the last step is to relate. That's the last step. So this is the kind of the answer. Yeah. But we still have to relate the C1, C2, C3, C4. Okay? We try to relate C1, C2, C3, C4. Okay? How do we do that? We plug this back we put this back into one of the original equations, and you can do it. Okay. Where do we want to put it to? We can do this. Which one you want? This one or this one? It's up to you guys.
Bottom.
The first one?
No, the bottom one.
This one?
The bottom one.
The bottom. Bottom seems nicer. The numbers are smaller. So we're going to plug it back, okay, into here, okay, using this guy here. Now, what does it say? Let's say, guys, say dy dt. Okay. Now, dy dt from here, dy dt will be equal to 5c3 e to the 5t minus 3c4 e to the power minus 3t. Okay. This guy should be equal to, it's supposed to be equal to x minus 2y. X is this guy. Minus 2 times y. It's okay?
Mm-hmm.
Now you look at this, compare coefficients, okay? For those two fundamental solutions, which are linearly independent. So we will have, we have this relation now 5c3 over this side, okay, will be equal to c1 minus 2c3. Can you guys see that? This guy is going to be equal to this together with this, right? Yes?
I'm sorry, I missed something. I didn't see where you got the 5 from, though.
Huh? You don't know where I get the 5 from? This guy?
Yeah,
I'm taking the y and take the derivative.
Oh, okay. Oh, okay.
Y dt. I'm looking at this equation here.
Okay, sorry.
So that is dy dt. And this chunk here, this chunk here is x. And this chunk here is 1. X minus 2y. Okay? Is it okay? What is the other equation by looking at here? What is the other equation? Minus
3c4
equal to c2 minus
plus c4, right?
c2 minus 2c4.
No.
Okay? From this, I will be able to solve c3, c4 in terms of c1, c2, or the other way around. Okay? It's up to you. I mean, your answer can be c1, c2 only or c3, c4 only. So from this, which one is easier? C1 is easier. C1 is equal to how many C3? 7 C3. Is that right? You guys follow this? C2 is how many C4?
-1.
So my answer is going to be here, I'm going to write down the answer here. This is the answer here. X will be C1 is 7 C3 plus C2, which is minus C4. Y will be that. Okay, so here's the answer. It's okay? This is the answer.
So professor, you basically only need 2 constants for the final answer?
Yeah, because it's 2 equations, each of them first order. There are only 2 parameters.
On the second line where it's eliminate x, is that equation 1 minus equation 3, right? Is that what you have written there?
Equation 1 here.
No. On the second line where it's under eliminate x, is that the second line? Yeah, is that a 1 or is that a D? I can't tell.
A 1.
Okay.
It's just an equation 1. I probably should have copied equation 1 over here, but I was kind of. I mean, it's this equation. Equation 1 here. This equation. It's okay?
Mm-hmm.
Kind of trying to save some board space kind of thing. By the way, I spent $50 on this whiteboard. $55.
It's a lot of money.
For the part with relating the constants, how do you know which ones to circle?
Relating the constant.
Towards the bottom, we have 5C3. Yeah.
You just look at the coefficient of these 2 guys. You look at the coefficient of e to the 5t. Okay. Okay. The coefficient for that should be equal on both sides starting.
Thank you. That makes sense.
Does it make sense now?
Yeah.
Because though the e to the power 5t and e to the power negative 3t, they are linearly independent. They form a fundamental set. So the coefficient has to be equal.
Are you still able to hear me?
So, questions? It's just a lot of computation. I mean, conceptually, it's not really that much there.
Professor?
Yes, shall we?
So if we have x, y, and a z variable, would it be 3 constants like C1, C2, C3?
Yeah, if you have another equation. You have 3 equations, all of them are first order.
Or is it the number of equations or the number of variables?
Number of it's the order of the equation. Okay. I guess you can look at it as number of variables. I mean, yeah, you can look at it as number of variables.
Okay, got it.
Yeah. Anything else, guys? You guys are good with this, or do you need some more one more example or something? I don't want to go too far. Huh?
I think we're good.
You're good?
I'm good, yeah.
Other people?
So am I.
Okay.
Feeling better. It's all good.
My answer is on the left top, on the bottom corner here, hands. No. It's x is x as a function of t and y as a function of t. Maybe we have some time left. I don't want to start a new section. Maybe I can show you. I won't completely solve it, but I will show you a case, an application where you will get a system of equation like that. That may be a good thing to do. Okay.
Will we ever be given a problem where we have to find the specific constants?
Yeah, I mean, I don't know what I will give you yet, but if you have an initial condition, right? If it is an IVP, an IVP will have x0 equal to something and y0 equal to something. Okay? You know what I'm talking about? Let's say this is 1, this is 2. Then you will have to put this into here. Okay? And find the constant.
Will we ever find like a second order differential equation?
No, okay, why don't we just do this here? Okay, we put in this initial condition and then we try to find the constant. Is it okay?
Yeah.
Okay, we'll do that. You find the constant up at the end. Okay, that's probably the easiest. Okay, we're going to just try to find the constant at the end. So I just focus on this now. Okay, I can even erase most of this. Okay, I can erase most of this. Okay. So just right here, plug in x equal to 0. Sorry, t equal to 0. This is t equal to 0. X will be 1. T equal to 0. Y will be 2, right? So t equal to 0. X will be equal to 1. Y will be equal to 2. So you plug in, put it in here. Will be 1 is equal to 7. C3 minus C4. 2 will be equal to C3. You guys got it, I think. You guys know how I get those equations?
Yes.
You just plug that initial value. Then this is now an IVP now, right? This is now an IVP. So what do we get? You add these two together. 3 will be equal to 8 C3. C3 will be 3 over 8. And C4 will be 2 minus C3. 2 minus 3 over 8. 13 over 8. It's okay? So your answer to this problem would then be x is equal to 7 times C3. C4, 13 over 8. C3, 3 over 8. Plus C4. It will be this now, the answer. Is it okay? That's a good question, Sylvia. Thanks for asking. You guys know what I did here? If you're given initial condition, you just put it in. Is it okay, guys?
If you have for x, it's 7 times C3, and if C3 is equal to 3 over 8, then why is it 7 over 8 e to the 5t, or e to the...
Are you talking about this step? Or the one after?
In your final answer, it says x equals 7/8 c to the 5t minus the one on the right of that. No, more further on the right, the box to the right. X equals 7/8.
The 7/8 is wrong.
Wasn't it 3/8?
7 times C3 is
21/8 or something.
Is it 21?
It's 7 times C3, so
Yeah.
it should probably be 21/8. Yeah.
Yeah. Thank you.
Yeah. Thanks.
Thank you. That's what you're talking about, right, Jenna?
Yeah.
Is it better now? It's good now?
Yes. Thank you.
Thank you. Thanks for pointing out the mistake. How are we doing, guys?
Feeling pretty solid. It's nice.
Okay. My what? My board is nice.
I'm feeling solid on the subject, and that is nice.
Okay.
But also your board is nice.
I thought you say the board is nice.
I hope they reimburse you somewhat.
That's okay. That's okay. Okay. You guys have no more questions? I can just show you this then. Okay. I probably don't have time to show you too much of it, but I just maybe just quickly show this to you. I'll just quickly show this example to you, okay? I won't finish the example, but since we have a little bit time left, I just want to show you this situation. Do you remember we have this mixture problem? You guys remember the mixture problem with the tanks?
Oh, the
With the
brine?
tank?
Yeah, I remember.
Okay, so here is an example where you have two tanks. Okay, you have two tanks. Say this is 4 gallons per minute. This is 1 gallon per minute. And this is 3 gallons per minute. And this one, 3 gallons. This is pure water. So this is 50 gallon. And this one is also 50 gallon. Actually, okay, so this is a situation where if you set up the differential equation, it will be a system of equation. We probably will try to set it up. We probably just have enough time to set it up. We are not going to solve it, okay? But you will end up with something look like this, okay? It's a system of equations. Okay, so xt is amount of salt in tank A at time t. Are you guys able to read my handwriting here?
For the most part, yeah. I mean, the quality is a little bit low, but that's with most computers.
Okay. Yeah, the board is a little bit low. Yeah.
Mm-hmm.
Yeah.
Although, like, when you're done, do you mind like standing to the right hand side of the board because you're kind of casting a shadow on it, and it makes it hard to take photos.
Okay. Oh, after I finish writing, I should move over. Is that what you're saying?
Yes.
Yeah, to the right hand side of the board.
You mean like this?
Yes.
Then you can see better.
Mm-hmm.
Okay. Yeah, sorry about that. I have a lot of constraints here because the height of the board is dictated by my nail already on.
Oh, okay. Oh. Uh-oh.
What happened?
Oh, something happened. Oh.
Is everyone still there?
Yeah, I'm still here.
Did
Can you hear
he
me?
just get kicked out?
It said somebody else is host now.
Oh,
Yeah.
probably it's time's up.
Said Jenna's the host.
Time's not up yet. Whoa.
Job away. Nice.
Should we invite him? Do we need to do that?
No, he still has access to the meeting. I think his internet just crashed or something.
Wait, so who's the host now?
I am.
Okay, so what's next?
Class.
I got
We're gonna start a
XP.
new chapter, I guess.
Just wait
I think
until
we have time for another example.
Joanna, let's go.
No, don't yet.
Wait.
Share your screen.
You took over his job.
Yeah, for reals.
You better be
Leave us
teaching.
alone.
Do you have the glasses?
So are we
Looks
sure?
like he got kicked off.
Are we,
How's
are we sure on
everyone
whether
doing with the quarantine?
How did he get kicked off?
I don't know. Unless
Does anyone
somebody-
need toilet paper?
He's
Darren,
not
did you check
participating
something?
anymore.
Anyone need some toilet paper? I'm selling like 50 a roll.
50.
That's a lot.
That's
There we go.
terrible.
There we
Oh,
go.
he's back. He's
Shit,
back.
this is some triple layer
Yay.
stuff.
Yeah, I run out of power on my computer.
Oh, hey, Professor.
Yeah.
I got a power supply now, so sorry about that.
Okay.
All right,
Okay.
Jenna, you're not the teacher no more.
Yeah,
You're fired, Jenna.
Yeah, I got connected to a Wi now. I just want to make sure I don't click on it. That's fine. I don't trip on it.
I have to pin it now again.
Amount of salt. I'll finish this. Okay. I'm sorry about that. It suddenly gone.
I don't know. It was only for like a second, so it's fine. We're just selling toilet paper.
Yeah, it's totally fine.
Okay, so why don't we try to set this up? Okay, we'll try to set this up. Amount of salt in you guys are okay. First, notice that. Can you notice that the level of the solution here doesn't change? Can you see that? Can you see why the level never change? Because this is 3 in, right? 1 in and 4 out. Can you see?
Mm-hmm.
4 in and 4 out. And here is also 4 in and 4 out. Yes?
Yes.
Okay, so never change the level. So dx dt is going to be equal to the stuff coming in. Okay? 3 gallons per minute, but the concentration is 0, so it's 3 times 0 coming in. It's okay? This is 3 times 0 coming in. And over there, this is another arrow coming in, plus 1 times the concentration from this tank, right? What's the concentration?
Y of t.
It's YT over what?
50.
Over 50. Subtract the stuff going out.
So it's 3,
This
4
is
4 gallons per minute.
10A. Okay. 4 times X over
50.
Okay, it just turned out to be both 50. So dy dt, you guys help me out. What's coming in? 4. Is it okay? Concentration is this. Subtract how much going out? Now this is 1 and 3, but you can add them together because both of them are going to be the same concentration. Is it okay?
Yes.
Mm-hmm.
Initial condition, x0 is equal to
25.
y0.
0.
Is it okay, guys?
Yeah.
Yes.
So this is an example where you actually set this up, and it will be this differential equation, and then we can solve it, but I am not going to solve it. These tanks can be legs. The legs are connected to each other, and some of them, I mean, they won't flow backwards, but like sometimes one leg will fit into another leg, right? Leg number one fit into this other leg. These are different legs. This leg fit into here, and I don't know. The Great Lakes, there are 5 of them. You know what I'm talking about? 5 Great Lakes.
Yeah.
Huron, Ontario. What's E? It's Xomes. Right? What's E? Erie. And then Superior. Those 5 lakes, they're kind of flowing.
Almost Cedar Point.
So you can look at this as pollutions. What is the concentration of the pollutants, and one fit to the next, and all this stuff. You can set up 5 equations. Okay, 1 equation for each lake. Okay, and then you can solve it using pure differential equation or differential equation and linear algebra. But this is kind of an example where this will arise. Okay. So on Thursday we're going to go to chapter 5, guys.
Okay.
Okay. So I plan to have office hours, not today, starting tomorrow. Have office hour Monday, Tuesday, Wednesday, 2:30 to 3:30. Okay. In case you have questions, the office hour is for everybody, for all the classes. So it's gonna be another, not the same link. Okay. I'll send you another link
Okay.
for office hours. So, any questions, and also any comment on? I think the setup works out very well. This Zoom thing is really impressive.
Mm-hmm. Do you mind putting the link on Canvas? Because I keep losing the email from you from like the 5,000 other emails for the district that are closed. So just so I don't lose it, I guess.
The link on what? This link is there, right?
It's already on Canvas.
It's on
Oh, it
Canvas.
is? Okay.
You just go to Zoom and then you'll find the scheduled meetings that he has on Canvas.
Oh, okay. Thanks.
I already have it on Canvas.
Okay, never mind.
Or you can just copy the ID code and then
go
to your Zoom and then paste and then log in.
Yeah, it's helpful that a lot of the students are very, very techy. So you guys actually, help me out a lot.
Professor, just to clarify, in case you are doing the online exam for exam 2, you said some about a test before the actual test, which is what you're doing for PAL 2, something like that.
Yeah, I probably will give you maybe just do a mock test or sample test.
Yeah.
Test like I don't know, with one simple problem. And you guys can play around with it, so we know what to expect.
Oh, I see. Yeah, that'll be great actually.
So it's not really a real problem. It's just, you understand what I'm saying?
Yeah, I understand.
It's just like, if you have any hiccup, it's probably better to know it earlier rather than during.
Yes, that's what I said. It would be a good idea actually.
Yeah. Okay, so anything else before we shut down? Sorry for the accidental shutdown earlier.
You're good.
Completely lie on me.
Time to barter.
This section is not too bad, right?
No, it's not.
Okay, we'll do chapter 5.1 next time. Is physics stuff. Okay, it's a mass spring system.
Oh, nice. Vincent will lead on that.
Yeah. Okay, so that's it for today, guys. Okay.
Okay. Thank you,
Bye.
Professor.
You're welcome.
Thank you, Professor.
Okay.
Stay safe.
Professor.
Thank you.
Okay. You're welcome. Bye bye.
Okay, thank you. Oh, okay, it's still going.